think we're probably live. Looks like we are live. Hello everyone! Welcome to the OneClass channel. My name is Millen and I am a software engineering student at Carleton University in Ottawa, Canada. Today we will be going over some commonly asked mathematics questions to help you with, and these questions will be at both the high school and college levels. If you need some help with homework or with some tutoring, check out the links in the description below. Awesome, so let's get it started with the questions that we have today. Just gotta switch over to my screen. Nice. So here is the first question that we will be solving today. So the question asks, which graph represents a geometric sequence? So we have four options. This is a little bit of a multiple choice type question. Our first option looks pretty line-like. Okay, straight line. Interesting. The second one, it's a little bit curvy. Interesting. The third one, it's a little bit curvy, but a little bit more sporadic. It seems to be curving down. And this one, I think that follows a pretty curvy pattern as well. It looks to be kind of like a parabola. Interesting. Okay, so let's to find which represents a geometric series, let's figure out first what is a geometric series. Okay, so let's draw this out. Let's get a thicker pencil. So a geometric series is a sequence of numbers, or a series of numbers, where each term is multiplied by something to find the next term. In this series. Okay, so let's say as an example of a geometric series, geometric series. We can have something like, we need something to start at. And let's say if we're multiplying by 2 every time, x2, so we get 2. Multiplied by 2 again, that's going to be 2 times 4, 2, that's 4. Multiplied by 2 again, that's going to be 4 times 2, that's 8. Multiplied by 2 again, that's 8 times 2, 16. And on and on and on. So to kind of easily tell if something is a geometric series or not, we can just divide the current term by the previous term, if applicable. Like, of course, we would not be able to do that for the first term. But we want to be able to see, like, our current term, if it has a previous term, if we divide them, we should always get the same number, no matter which term we're looking at. So 4 divided by 2, hey, that's 2, makes sense. 8 divided by 4, the previous term, that's 2, makes sense. 16 divided by 8, which is the previous term, that's 2, makes sense. We should look for that type of pattern among these graphs, and let's see if any one of these follow this pattern. And if it follows that pattern, we know it's a geometric sequence. Series and sequence, they're kind of similar. Yeah. So let's take a look at the first term. 1. The first term is when it's 1. Its value is 1. The next value, 2, this value is 3. Let's do, okay, if we divide this from his previous term, 3 divided by 1, that's 3. We should take this and divide it by his previous term. 3 divided by, or 5 divided by 3. Oh, that's not the same answer that we got the first time. Let's say for up here, that's the 5th term. So that's 9 divided by 7. Hey, that's not 3. It seems like we cannot, there's no pattern or there's no number that you just multiply to the current term to get the next term. Because if that was the case, the number would be changing every time. And that is not what you would call a geometric series. Okay, so we can basically say A is no, not geometric. In fact, A is actually linear because you're always increasing by 2 between turns. So this is linear. Okay, cool. So let's look at B. Okay, let's look at the second term. It's multiplied. It's 2 times bigger than its previous term. Okay, 2 is 2 times bigger than 1. Makes sense. Term 3, 4. Term 3 has a value of 4. This is also 2 times bigger than its previous term, 2. And the fourth term, 8. Hey, that is also 2 times bigger than its previous term. This actually perfectly follows the pattern that we have here. I promise I didn't look at this before and use this as the example, but this really does follow our pattern. We can see that every term that we're looking at, when we divide the current term by the previous term, we always get 2. So we can write B is geometric. Every term is double the last, or double the previous. Okay, awesome. Let's take a look at C. You know, even though we found B and B is most likely going to be the match, let's make sure that we can disqualify the other 2 options from our question, from our options. Okay, so here we have option C. The first red flag is that, okay, our terms are not numbered in the greatest way. They're not 1 apart. They seem to be like, first it goes 1, and then it goes to 4, and then it goes to 9. At 4 it's 4, at 9 it's 6. It seems like the growth rate between the increase in y is pretty small compared to the increase in x. So its growth rate the growth is going to be smaller and smaller. Like the distance, the height change. Like initially we had a height change of 2 over a horizontal change of 4. Then on the next term we have a height change of positive 2 and a horizontal change of 5. This is going to be growing at a smaller rate, which is not what we observe with geometric series. Geometric series, you see the more terms you are deep into your sequence, the faster the growth rate between terms becomes. And here, we don't really see that pattern. And I think the main red flag is that these terms are not perfectly beside each other. So either we're skipping terms or something else is going on. Regardless, there are multiple things about C, like the growth rate decreases. And terms spaced out weird. It's probably the best way I can describe it. Regardless, we're disqualifying C from our possible options. And let's see if we can disqualify D. Well, its first term is 1. The second term is 4. So we divide the second term by its previous, we get 4. Okay. The third term, we get 9. 9 divided by its previous term 4. That's not 4 like we got for our previous. So this does not follow the geometric rule. It's actually a parabola, because it seems like the y value is just the x value squared. Like you see here, x value is 1, square that, becomes 1. X value is 2, square that, you get 4. For x value 3, you square that, you get 9. This is a parabola. Which is certainly not geometric. Because you're squaring your term number instead of multiplying something to your previous term. Remember, that's the golden rule for geometric sequences and series, is that every term divided by its previous term should give you the same number. You're always multiplying your current term by something, the same something every time to get your next term. In this example, we have times 2. This can easily be times 3, 4, 50, times 2 million. All be the same geometric series. Sounds good? Okay, so here in the answers, we got a choice B. And should we... I think the above solution is correct because... yeah, the above solution is correct. They disqualified everything that's not B. So, the above solution is correct. Awesome. So, we can move on to the next question on this.